So I'm not sure if we're going to get any more people, but because I've got 72 slides, no. I just want to get started because I want to give you all the time we have. So quick introduction, my name is Dan Elder. I am the Linux Services Manager for NovaCoast. We had a booth out there some of you might have stopped at, but I'm here to talk today about Docker and Ceph, how you put them together. And with me is my lovely Vanna White. Go ahead and introduce yourself.
David Parker, also with NovaCoast, just here to help out and interject questions.
And what is it you do for NovaCoast, Dave?
I run our security assessment business. So people hire us to hack in and dig deep and uncover problems and then tell them how to fix them.
He's a bad man. You don't want to find him on your network. Okay, so starting out, let's go through the agenda. Again, if there's topics you guys want to see, anything at all, questions, please stop. Let's make this interactive. So we talk about containers a little bit because not everyone's played with Docker or containers of any type. So I want to go through the basics there of what they are, how they work, where they make sense. I'm going to focus a lot on where they make sense because far too often people try and put the wrong types of applications and workloads in containers. And that's going to feed into 12-factor applications. What type of applications make the most sense for this, both in the Docker world and because we're using Ceph as the backend, what's going to fit best there. Talk a bit about the security benefits of Docker. That's a really important thing to understand because most people kind of gloss over that and ignore that there's some huge benefits. And then we'll talk about Ceph. Some of you are new to Ceph, so we'll start off with a little bit of a, oh, sorry, thank you for that. We'll talk a little bit about what Ceph is, how it works, and then where it fits. And then we'll talk about why Docker and Ceph together, why this is a really great fit. And one of the things we're going to focus on is CephFS. CephFS is obviously not the only way you can have Docker talk to a Ceph backend, but because it's easy to demo, and I like easy, I went with that. And we'll talk about winning. Anyone like to win? I like to win. There we go. There's some winners out there. So containers. What are containers? So show of hands, who hasn't used Docker at all or anything containers? Okay, perfect. So there's a few of you. So going through, what are the benefits of containers? Well, in traditional application workload, you've got your app sitting in a VM, or maybe on physical hardware, but usually VMs. And with that, you've got all the overhead of not just the operating system, but all the associated services with it. Maybe your logging system, your antivirus client, your backup agent, all these different things running on top, when all you need to get to is really just that workload, that application that's sitting on top. Whether it's a web server, database, whatever it is, you only care about that. The other stuff's just there to make it work because it's a dependency. What containers do is strip that whole model down. So you've still got, and I apologize, it's a little bit small to see here, but instead of having that hypervisor and everything else getting between your application and the physical hardware, which is where you get all your performance from, you strip out all those layers. So in a container, you've got the libraries that an application needs to run, and that's it. You don't have all these other services running. You're just running your application, nothing else. So there's still a host OS underneath, in this case Linux, but on top of it is just your application. And it's confined to these containers, so it's easy to package up, distribute, run anywhere. You can do a lot of really powerful, very easy things. And if you're someone who pays for all the hardware, all the virtual infrastructure, everything else, you appreciate the consolidation too. That's a huge cost savings for most environments, both in just the servers themselves, power and cooling. There's a lot of different factors. Out of that, you also get very rapid and very consistent deployments. Anyone here really enjoy going all the way from dev to production, that whole workflow? Does that work smoothly for everyone? No, it never works. There's always something different between one of your environments, and things break along the way. You don't have a nice consistent, oh, I tested it here, I know it's going to work all the way up the stack. You have to go through and do it at every single layer, and it's painful. And your developers hate it, your ops guys hate it. It's miserable to work with. So with containers, because it's so easy to package these things up and have it totally isolated and self-contained, you can take the exact same thing you're running in dev, that same exact container is going to be deployed in production. The only thing that's changing is some of the environment variables of where your database lives or where whatever else lives. So it's a very easy way to really get things where they belong and know that they're going to work. And it helps bridge the gap between developers and operations. Traditionally, you see it quite a bit, there's a divide between the operations folks and the dev folks. It's one of those things where you probably see the meme of the evil little girl smiling and said, worked fine in dev, it's ops problem now with the house burning down. That's exactly where a lot of this comes from. By having everyone work together, including your security team, you're eliminating a lot of problems because instead of having these siloed groups that don't work together, now they're kind of forced to work together. And when you force people to work together, guess what? They come up with better solutions usually. We'll talk more about this in the security section, but you're getting an end-to-end audit trail. Instead of having a VM or some type of system where it's been there for years, you don't know what changes have really been made to it. 5 different admins have come and gone, and all the time it's been configured. Who knows what's actually on that system? It's pretty difficult. In the container world, when you do this the right way, from the time an image is created, you can see exactly in a very easy to audit text file how it was built, what's in it, how it's configured, all those pieces that are really important to understand if you want to know what's running in your environment and not have all those special little snowflakes. The goal there is really just to standardize your workload deployments. You care about your workloads, you care about your applications. You don't care about everything else around it other than it's there to support it and make it work. So the more seamless we can make that to deploy, great. And of course, we're here at SUSECON. Docker is fully supported in SLES, version 12 and above. There's a lot of great things. If you have questions about support levels, Lars is your guy. Go ahead and pester him with questions. I know you're here for Ceph, but I'm gonna pin everything on you because you walked into the wrong room. Sorry, buddy. Okay. Lars is a great guy for anyone who doesn't know. So,
question on that slide.
Yes.
You know how there's no plans for OpenStack for VMs?
Yes.
What's the analog? Like I want to start a container in an OpenStack environment, or is there?
So I mean, you can use Docker with OpenStack. You can do the same types of things with the same type of backend. So for example, I'll be showing CephFS as a backend for where I'm storing my, and not this is, so backing up a little bit, there's the images themselves, which of course you need to store somewhere. And that's where block storage and object storage and figuring out which one of those is going to be best matters. But then there's also the state side of it, and I'll get into that more later. But so Docker images by themselves, if you do it the right way, they're completely stateless. If that image gets blown away, it doesn't matter. There's nothing important. You just spin up a new one, and you're off and running. Obviously, you still need to have data that lives somewhere, though. So if I'm running my database in a Docker container, I don't want any data within that container, but I still need it to live somewhere. And that's where the Ceph side is going to come. And there's a lot of different ways of access. So we could access it through object storage, through CephFS. There's a few different ways. But so looking at the analog from the OpenStack world is kind of we're going to be looking at where, not so much where the image lives, which is what OpenStack is more focused on. We're going to be looking at where the state, the data from those containers lives. Does that make sense? Okay, perfect. Perfect. Good question. That man gets a shot glass. Another one. For those who came a little bit late, if you ask a question, you get a shot glass and a screen wipe. So again, make this interactive. All right, what are some of the security benefits of Docker? Well, when you do it the right way, there's no access to production. Your containers are built and tested in your dev environment, QA, whatever you want to do it in. And then by the time they hit production, there's no command line access to it. So you're eliminating a huge security threat by not allowing access. And it's a big paradigm shift for a lot of environments to kind of really embrace, because if something goes wrong in prod, your instinct is to go in there and fix it. And you can do that in the Docker world, obviously, but if you've tested everything correctly beforehand, once you put it there, these might be immutable instances where you can't make changes. So someone can't actually break in and do anything bad to your environment. That's a pretty powerful way of doing things. Again, if it's stateless, if it's an immutable container image, no one can make any change. It doesn't matter what I put in memory, what I put, even if I somehow break out of that and put something on there, you spin the container back up the next time and it's gone. So all your advanced persistent threats, all those types of attacks, that whole vector goes away. Good way to do things. And these images themselves are very minimal. Typically, when you're installing an application in a VM environment or anything else, you're installing a full OS, you've got 15, 20, 30 services running. All these different things open, exposed, that really don't help your application run, but they're part of the OS and part of everything else. And it's, in addition to being a lot of overhead, it's a much bigger attack surface. So by eliminating those vectors, by using these container images, which are only running one thing, and that's your application, you're really shrinking that footprint down of what you need to protect. The way you deploy these things allows for very rapid response. When Shell Shock came out, internally all of our applications are Dockerized with the exception of Exchange and SAP. The vendor patch came out from SUSE, hit our SMT server. Based on the CVE rating, or the score and the CVE ratings and everything else, it automatically triggered all of our Docker images to rebuild themselves. They went through all of the unit tests, the regression tests. When those passed, they got pushed to production. The software load balancer drained the connection pool to the old one, stood up the new one, blew away the old environment, and within about 15 minutes, our entire environment was rebuilt and deployed in production without us ever lifting a finger. We got an email at the end. So, and it takes a long time to get there. This isn't something that you can build out overnight. There's a lot of pieces beyond Docker, beyond Ceph, beyond all these other things that you need to get there. But that's kind of your end goal, is to be able to redeploy your entire environment in a matter of minutes to be able to respond to a threat. When these new zero-day attacks come out, you don't have time to schedule 6 months out when I'm going to apply these patches, when I want to do these things. We don't patch. You rebuild and redeploy, and you do it very, very quickly. Again, we talked about the audit trail. This is important. I can't emphasize this enough, particularly if you're in a regulated environment. Being able to show an audit trail for exactly what is in your environment from the time it was built to the current time, which really should be about the same, is fantastic. Anyone here deal with PCI, SOX, HIPAA, obviously? Yeah, so your auditors love seeing audit trails, don't they? They love to know that you've got the controls in place to ensure everything's the way it's supposed to be, all that stuff. It's a lot easier to do in a container model, because you can't make changes. And if you do, you have to be rebuilt and redeployed, and you can see exactly where that happened. Again, we're all about breaking down those barriers. When you get the ops guys working with your developers, working with the security team, and everyone on the same page, understanding how applications work and how they interact with each other, it solves a lot of problems. I can't tell you how many times I've worked with application teams where we're trying to secure the system and ask them, well, what does this really need access to? What does it do? I don't know. It's important to understand that. If you don't understand how your applications work, how they interact with the rest of the system, you're going to have a heck of a time trying to secure it. So by getting all those groups and forcing them to work together, because you have to know those things to deploy this right, you're going to solve a lot of problems and understand where your vulnerabilities are, as well as what the architecture looks like and how to mitigate those threats. And then there's the classic one. Humans make mistakes. We all do. You fat finger something, you're trying to make a fix at 3 in the morning, you're deploying production in the middle of the night because that's when your change control window is. Whatever it is, humans make mistakes. We all do. If you can automate it though and make it a totally repeatable process, you're at least eliminating a large amount of those human errors. That doesn't mean you can't automate something catastrophic by making a human error, but your odds are going to be better of catching it, and even if you don't, you can respond very quickly as well. So, yes, question? Oh, no, sorry. You can still get a shot glass for that, though. No? Okay, all right. More questions later. We'll get you. There's also great security tools around it, AppArmor, SULinux, whatever your preference is. I personally really like AppArmor, but you can write all these confinement tools. And this isn't container specific, but you can use it in containers too to really isolate what the applications can do, what they have access to, which POSIX capabilities they have. So I talked a little bit before about 12-factor applications. Yes, question?
Before we move off that slide, I'm just curious, anybody in the room that's using Docker containers, is that a benefit, the security benefit, something you enjoy, or is that just a side benefit? Anybody seeing these benefits for that reason? Not really. That's surprising to me, so that's why I asked.
Well, you may have that exactly.
Yeah, a bunch raise their hand. What? In the room.
Yeah.
A bunch aren't using it.
Yeah, so Docker is still new for a lot of organizations, but that's why I kind of highlight the security benefits, because everyone likes resource consolidation. They like making automated, consistent builds. Those are all great things to have, but it's important to understand the security side as well, because we're increasingly seeing far more dangerous attacks. The traditional hacks in the past were focused on stealing information, selling it, whatever it was, embarrassing people, and that's kind of as far as it went. The attacks you're seeing today, they're trying to destroy your business. They want to kill your organization and burn it to the ground. They're going to take all your information. They're going to release everything embarrassing they can on the internet. They're going to DDoS you into oblivion. They're going to wipe everything you've got. If you don't have the right type of security controls and tools in place to deal with those types of things, you're done. Yes, sir?
Well, question. When it comes to the security, like you mentioned before, I remember hearing about SUSE Manager and combination, combining that with Salt.
Yes.
Okay, that you can use with respect to checking out containers for vulnerabilities, and so on and so forth. So, is this going to be another piece within Docker to check for that, or is this something that Salt is using to check for those vulnerabilities?
So it's a great question. So I actually haven't, unfortunately, made it to the SUSE Manager talks about Salt and Docker and how those interact. I wish I had right now, but it's kind of a different way of looking at how, there's multiple ways of doing this. So for example, you've got tools like ZipperDocker, which can actually patch your images, do some things like that. And so that's more the traditional patching philosophy. And that's great if you don't have all the other tools in place to fully automate everything, because you don't have the full CI build process just laid out already. Very few organizations do. And so tools like ZipperDocker and SUSE Manager and those pieces, those are great for managing and keeping everything consistent and patching and whatnot. The model kind of eventually, though, when you get to it, though, is you're not managing your containers. Anytime you're making a change to it, it's on the build side. You're rebuilding and redeploying. So that's kind of the end goal, but it takes a long time to get there. That's why it's great having these other tools to help get you there.
Yeah, just to add to that, looking at the security side from my perspective of breaking in and from the bad guys' shoes, in 15 years we've never not broken in. And I'd say 95% of the time, we're getting in at some point in that stack of issues is because there's a missing patch or a system that someone forgot about or that snowflake that didn't come from that automated DevOps and build methodology. So now you're not patching anymore, you're just breaking stuff down and rebuilding. You don't have that problem.
Right, because I mean, at the end of the day, we're really, because that container only contains those few libraries that the app needs and not necessarily a full kernel or a full OS within that container. I was trying to see as to where that breakdown was between checking out the container with the libraries in it and the actual underlying OS. So it would be more on the lines of Docker would be able to watch the internal container and the vulnerabilities possibly within it from a library perspective.
Mm-hmm.
And then other tools around it might be able to just complement the entire environment. That's all.
Yeah, so SUSE has the tools to do it that way, and certainly you want to manage your SUSE Docker hosts too. They're not Docker images, they're a full-blown OS. You still need to patch and manage and keep them going, obviously. But the containers themselves, the end goal is kind of to get away from managing them. Once they're deployed, think of them as they're immutable. They're set in stone. You're never going to change them. When a patch comes out, when a configuration change needs to be made, rebuild, redeploy. Blow away the old ones. But yeah, there's tools to get you all the way across because it took us 2 years to get to where we were fully Dockerized. It's a major process. So having something in the meantime to help as well as manage the rest of your environment is great. And also it's important to note that you're not going to Dockerize all your applications. It'd be great if you could, but there's a whole world of legacy applications that don't fit that model well. Shot glass for this good man. So 12-factor applications. I'm going to go through this really quickly in the interest of time, but the key thing here is to understand, you can read these at your own time. It'll be in the slide deck. You need to understand that not all applications are going to fit well in the containerized world. You can fit them in. Sometimes it's going to be really kludgy and ugly, and it's just not worth it. So it's really your microservices, all your really modern, very distributed architectures that are going to fit best in this model. Those are the perfect way to start. Not every application is going to be that way. Like I said, we have not Dockerized our SAP environment. Anyone here want to try that? Yeah, have fun. Well, we are actually. Yeah, we actually have Dockerized pieces of it, but getting it supported by SAP is a slightly different story. Yeah, no, I like getting my paycheck every month, so I'm not going to touch that one, yes. Very good point. So it's not for every application you've got, but these are the types of things you should look for. So having a common code base, tracking it and revision control, obviously very important. Having all your dependencies clearly stated and isolated. That goes back to understanding how your application interacts with the rest of the environment. Most developers don't necessarily know that, and the ops guys don't know either. You got to get them both talking together to figure out how all these pieces work. Storing the config in the environment, not having it hard-coded and built in and jumbled away in 50 different places. I want to store that in the environment, be able to pass it as easily as possible so that it's very nice and abstract that I can work with. The key things here, backing the services, we're going to be talking about volumes as one of ours, but all the different pieces, having them linked together and whatnot. Build, release, run, we want to be able to have that all set up so we can do things quickly. Processes, they should be as minimal as possible. So you don't want to run 50 different applications in a single container. It kind of breaks the whole model. You want to have it stripped down as small as you can, ideally to a single application. Port binding, blah, blah, blah. The scale out model is more important than the scale up at this instance. Disposability is important. Like we said, when we push out something new, the faster you can take something down and spin up a new one, That's ideal. If you've got a 2-hour startup time on a container, that's kind of a weird use case. I don't know what you're doing, but it's probably not going to be the best fit. Keeping dev and prod parity. That should be a goal for everyone everywhere, but it's a lot easier in the containerized world if you've got applications that can support that. Some applications are incredibly complicated. They're like spaghetti monsters reaching into every different part of your network. That's going to be a hard thing to Dockerize, so that's not the ones I would start with. This is an example of what you want to start with, and if your application doesn't fit into this model, the further it strays, the harder it's going to be. Logs are important, obviously. Admin processes are important, but you can see all these and get a great idea of what they all mean and how to architect your network and your applications this way at 12factor.net. I highly encourage you to read that. Just a good little manifesto there. So now we're getting into the Ceph side. Quick show of hands because a few more people came. Who here is using Ceph? Excellent. So we've got a few of you. So I'll make the overview a little bit quicker than normal. So what is Ceph? Well, the important thing to understand is it's enterprise ready. Has been some time. Some of the largest environments in the world, like the Large Hadron Collider, they use this for all their very critical data. So this isn't someone's hobby open source project. This is something that's enterprise supported. SUSE has got massive teams of people who can make this all work for you. So it's also massively scalable. Well, scalability is important because anyone here has their data shrunk over the years? It's going down, you're just getting rid of old sands and you don't need anything? No, data is exploding. We are having to constantly deal with more and more use cases for data. And all the data that we used to throw away, all of a sudden people are finding new ways to use it for business analytics or whatever else. And so now you have to hold on to it for longer. Maybe it's for regulatory reasons. You need something that can keep up with that, something that scales. And that's exactly what Ceph was designed to do. You can kind of think of it as the way Linux grew into and took over a lot of the proprietary Unix space because it was commodity, ran on commodity hardware, it was very cheap, and you're able to scale out. Same way with Ceph. We're not trying to scale up, we're trying to scale out. It's massively, massively scalable. It doesn't matter how many petabytes you have. Throw whatever you want at it. Open source. Open source is important for a lot of reasons, but cost is usually the biggest factor for people. Having a community behind it, multiple vendors, everyone else supporting it and working on a common goal, that reduces the cost right up the front. So open source is obviously free. You can go with no cost, but even for enterprises to support it like SUSE, it does not cost them as much money because they're not the sole developer. They get to work as a team and spread that cost across multiple organizations. So it's, open source is great, it's powerful, there's a lot of change, very rapid, and it means that you as a customer aren't beholden to what vendor X thinks you should have. The whole community gets to come together and decide, and by the way, if you don't like what they're deciding, you can contribute and do it yourself. Anyone here gonna do that? No, probably not, you wouldn't be in this top, well, okay, fair enough, Lars will because he's in charge, but the rest of us just get to enjoy the benefit of his work. Commodity hardware. Well, commodity hardware is cheap. You can run Ceph on any hardware you want, just about. x86, now ARM. I'm sure more architectures will be coming, but you're not stuck with a single vendor. You can pick whoever you want, mix and match, and make it work exactly the way you want it to. There's a very large ecosystem around this. This is not a SUSE-only product. There's many vendors that are contributing and actively working on this. We'll go in a little bit why we think SUSE is the best option, but you're not stuck with a single vendor, just like the hardware can come from anywhere. There's a lot of people working together collaboratively on this. So you've got, architecture-wise, you've got your storage nodes. Those are kind of what you think they would be. They're x86 or ARM server with a whole bunch of disks in them. Nothing too crazy there. Then you've got your monitor nodes. Sometimes that's going to be on your storage nodes, but they could be on your gateways, depends on how you're architecting things. And let's see, I'm going to use this nifty laser. Can anyone read any of these words on here? Probably. It's pretty small. So I won't go through the graphics too much. You'll be able to download the slide deck, I think, at some point. You can look at the architecture overview. The SUSE documentation is far better than my slide deck. I would use that instead. We've also got these gateway nodes. The gateway nodes can be different ways for clients to interface with this whole storage architecture. So it's different than, you look at a SAN, you've got a controller, you've got the different arrays attached, and it's all very centralized. In the Ceph world, that architecture kind of, again, scales out. So you can have lots of different storage nodes, which obviously you need to put the data somewhere, but then you've got these front-end nodes that clients can talk to and other systems, so you can kind of scale it out in a lot of different ways depending on what your performance needs are. Maybe you have a caching tier because you need higher performance. All these different things you can do to really make it more interesting to work for your business. So now we're going to get into the fun stuff a little bit. Why should I use Docker with Ceph? Any questions so far on that last slide? Sorry, I jumped. Yes, sir.
I wanted to try this out. Is there a way can you combine those storage and monitoring gateway nodes at all, or does it have to be completely separate?
No, so if you're just trying to play around with it and test it out, yeah, you can combine it. The performance is going to just be atrocious, but yeah, you're not looking for performance, you're just looking to play with things. Yep, exactly, yeah. So in a production cluster, you wouldn't have fewer than probably 6 nodes, but for testing purposes, yeah, you can combine services. Absolutely, great question. Anyone else? All right. So why Docker and Ceph? Why are we talking about the two of these together? Because why am I talking about storage and containerization? Where's the synergy there? And the reality is there's a lot of different reasons you should be looking at that. Obviously not the only way of doing things, but we think it makes a lot of sense. So the reason you should be looking at any type of storage with Docker is because you want to have your containers be stateless. Again, it's really critical that you're not managing containers. You're not managing the data within those containers. It really breaks the whole container model. You want to be rebuilding and redeploying. So those containers are going to sit there fairly static, but they still have to, the container images have to live somewhere. And more importantly, state has to live somewhere. And by state, we mean the data. So whether it's a database, keeping all of its data somewhere, or it's a web server that has, I don't know what, stored somewhere else. You do obviously need to have stateful data. You can't just throw all the data away every time. It's not going to do you much good. Some workloads you can. If I've got maybe a DNS server, I statically load up the zones, and once it fires up, it's off on its own, and I don't care. I blow away and start with a new one. Most applications are going to need some type of state. Maybe their state is just going to be the database server they talk to, but there's still somewhere this data all has to live. If you're not keeping track of that somewhere, it's not going to work well. We think Ceph is a great option for that because it scales just as well as the rest of your environment does. And in terms of being cluster ready and cluster aware, it's very powerful there as well. Well, stateful data. There you go. I jumped ahead a little bit. Sorry. Location-independent access is important. I can store. So when you spawn a Docker instance, you can tell it when you're spawning it where to store particular volumes. And volumes are just subdirectories within that container. So if I've got a MySQL instance, I can tell it, I want this instance, when it starts up, to map var lib MySQL or wherever you're mapping things to this directory on the host. And you can do that with all your different Docker hosts. And the problem is, if you do that locally on each system, and so I say my database server in this Docker instance lives on host A, and now I'm using this directory on host A to store data, that works great while it's running there, but what happens if that Docker instance has to move to another Docker host? That data is no longer accessible. You need to have all that instance information, along with Docker images and those other pieces, obviously, somewhere where all the hosts can access them and be able to access them simultaneously. Not because they're going to be writing concurrently to the same data, that's going to cause problems. But if I need to spin something up somewhere else, it needs to be where all the hosts can get to it. That's kind of a really important one. Does that make sense to everyone? So your data needs to live where everything can get to it. This is where you get into clustered file systems or object storage, lots of different ways you can achieve that. But you have to make sure that your data can be reached by everything. Well, David's going to clarify for me, everything that should have access to your data. You don't want it to be accessed everywhere. This is one of the reasons we really like SUSE Enterprise Storage is robust access protocols. There's a lot of other vendors, distributions of Ceph out there. They do not support nearly the range of ways to access data as SUSE Enterprise Storage does. So Ceph will let you do things via object storage, which is where Ceph really got its roots, its foundation. But you can also access it via iSCSI. CephFS is fully supported. Anyone here know what CephFS is? Sorry, I keep throwing that term, out, and I realize I should probably explain it. So CephFS is a layer you can put with Ceph. It's a way of doing different volumes, and it basically gives you a clustered file system. So you can access it via a Fuse client. It's in kernel, but you can map volumes to it natively. So rather than having an iSCSI LUN that I'm targeting, I've just got this pool of storage that appears as a native POSIX file system. So if you're in the Linux world, that's really handy. Previously, the way you might do something like that if you weren't going to use object storage is maybe you create an iSCSI LUN, map it to an NFS server, and then export it to your Docker host, which certainly works. But this eliminates the whole need for that. It happens right there within the Ceph environment. Yes?
I'm assuming SUSE storage supports using Ceph from Docker.
Ceph with Docker?
Yeah, do you happen to know if they do or not?
Yes, my question is
Using RBD, sure.
If you don't know if that's okay, I can ask SUSE if that just occurs.
Is running Ceph in Docker or in Ceph with running Docker containers back with Ceph?
Well, running as he's describing.
Yeah, so using something like CephFS as the back end for Docker.
Yeah, true. So running Ceph is and accessing it from Docker.
Yeah,
we support it.
Yeah.
Yeah, okay, thanks. Thank you.
It's
Does the RBD work? Because I can, does it?
So there's a lot of different Docker drivers. So you can do it through RBD, you can do it a lot of different ways. In terms of support,
It's a kernel driver, so as long as you map it on the host and then the container can access it, sure.
okay. So
Well, it's a kernel driver, so it has to, that part has to be mapped outside the container. Any
Yeah.
kernel part breaks the container abstraction.
yeah, and well, so architecturally it's important. You're not really necessarily mapping to storage from within a container. When you launch that Docker instance, you're telling it where on the local system to map to. And so that local mount point is just your RBD mount or whatnot. And I'll show that with the demo in a little bit. I'm using CephFS, but same with RBD. The Docker containers themselves, you don't need to modify them for CephFS. You don't need to modify them for RBD. You don't need to modify them for iSCSI. They shouldn't know or care how they're accessing that data. When you're launching the instance on the host itself, the host is mapping whatever that remote storage is and just presenting it as a directory to that container instance.
You're going to show us how that works, so the layers.
Yes, yeah, so I'll show a demo of what that looks like a little bit. The important thing though is, because I don't have a lot of time for demo, everything I'm going to be showing you is right out of the SUSE Enterprise Storage docs, aside from the Docker piece, which is really easy. I'll show you that all you're doing there is a mount command. But yeah, the SES3 documentation, if you read it, it walks you through exactly how to set up CephFS. And that's all I've done here is line by line. I made it as simple and basic as possible. But yeah, I want to talk about the architecture of how that works, because that's important to understand. Your Docker containers, they should not care or know where that storage lives. It's just getting mapped to them when they're being created. Does that make sense? Perfect. Scalable, we've covered that a few times. Open source. Both Docker and Ceph are open source. That's very powerful because, like I said, there's a lot of different drivers you can use for Docker. You can actually, at the Docker side, eliminate kind of a lot of the host stuff that we're doing here today and use some of the different drivers like Flocker, things like that. You can do some really interesting storage stuff right from within Docker to access Ceph. I'm showing a very basic, easy thing to demo, but there's a lot of other options out there. And those other options are out there because both products are open source. It's very easy to see how they work, make modifications, and while most of us in this room aren't going to do that, Lars excluded, for the rest of you, you get the benefit of having a whole army of people who want to tinker with that, try new things, and make it work together. So open source is very powerful that way. You're not going to see that type of integration generally with proprietary solutions because it takes a long time to figure out how they work, get everything dialed in. It's quite a bit more cumbersome. So the rapid pace of development of both technologies really helps them work well together. And support. We like having support because data is important. Anyone here would have a good day if all their storage went away? No. That's a very bad day. So having someone you can call if that happens, or having someone give you those best practices or help you out when you're setting up those things, those are all important. Quick plug for NovaCoast, obviously. We're a consulting company. We'd love to help you get these types of solutions up and running, but that's why we're trying to get the ball rolling here, because support's important. Understanding how this works and how this ties together, very important, because at the end of the day, it's all got to work. And while it's great if we could do everything ourselves, we often can't. So a little bit more about CephFS. There's a nice little graph here showing the different layers of how it's accessed. But when you get down to it, at the bottom, we have OSDs. Those are just, think of them as systems serving up storage. They've got a bunch of spinning disks or SSDs or whatever they are. Data has to live somewhere. It lives on the OSDs. We've also got our MDSs. These are our metadata servers. Interesting thing with CephFS is when you're creating these storage pools, for those of you who've used Ceph before, you're going to create two different ones. You want one for your metadata and one for the data itself. And you put all the really fast stuff on SSDs, the metadata. It's really important for performance reasons. Otherwise, your access is difficult. Does anyone here use clustered file systems? What's the performance like for you, particularly with small files? Exactly. It can be a little bit rough. So architecting that the right way is really critical for performance. CephFS is no different. And then we've got our monitor nodes, which use our crush maps to keep track of all the data locations, everything else. So that's our bottom layer. This is everything Ceph. Then we've got our storage cluster. It's going to be accessed through Librados. And then on top of that, we've got our CephFS library. And then there's two ways clients can access these CephFS volumes. One is they can do it in kernel. This is the way that it's done in SLES currently. Do you know if there's plans to release the Fuse client for?
I know that there are plans to not release the Fuse client.
Okay. Is that for performance reasons or support reasons?
It's for support reasons. We would rather only support one first.
Okay. So there you have a very good definitive answer. But so you can do it in kernel or you can do it with a Fuse client. The challenge with Fuse clients traditionally has always been performance. I'm guessing that probably plays a decent role in why that decision was made. Doing something in the kernel versus Fuse is going to be a lot faster. And only having to support one is also pretty nice. So the thing about CephFS is it's giving you a fully POSIX compliant file system on top of Ceph. You can create your Ceph pools and everything else to be terabytes and petabytes, however big you want. Is there a support limit to CephFS volumes?
Not realistically.
Not yet. We'll hit a wall for you.
If you hit by the time you hit the sizing limit, it's in the peta or exabyte range.
So yeah, so the good thing is this is very extensible, very scalable, and it's fully POSIX compliant. So you're not modifying your applications to support weird file system semantics. And this is one of the things that made object storage so hard for organizations to adopt, is you really had to modify your applications, the way they work, the way they interact with the storage. And so Ceph was great for those few organizations like CERN who could do that. But for most of our use cases, it's not a great fit. Having something that's fully POSIX compliant out of the box with all the scalability and everything else of Ceph is very powerful. So that's a nice thing. The MDS options. So your metadata server is a critical point of failure with your CephFS deployment. It keeps track of all the file system type information you normally think of, and it's important to have. So you don't want to generally have just one, but you can only through support have one active at a time. So the failover type configuration there is still something you want to architect very carefully, keeping in mind that for now at least, active-passive is the preferred way of distributing those. Is there a timeline for active-active or any?
So active-passive is not, so that's automatic. It's not really, it's magic from the point of view of users. A failover happens internally or automatically. The other MDS has all the data in memory, it's cached, it's hot, it's primed, it's ready to go. So that's fine. And the multi-metadata server is mainly relevant not for availability but for performance. And that will happen according to our current roadmap for SES5. So that needs, it's in the current development version, but it needs some time to mature because it's actually a pretty tricky problem to do right.
Sure, yeah. So again, thank you, Lars, for being here. This is excellent. You get a lot of answers right from the source. But yeah, so the important thing to understand is by the time you're deploying this and using this, that'll all be, for scalability reasons and performance reasons, it'll be even better than it is today. So go ahead, try it out now. It's fully supported. By the time you're hitting exabytes of data, it'll be performing even better. There's a lot of performance considerations to CephFS. So again, things like making sure your metadata and your volumes and metadata servers and things like that have access to higher performance storage, your SSDs, your things like that. You can save your storage costs still by putting SATA in other areas, but as with everything else in Ceph or everything else in storage in general, you've got to figure out where to put the right pieces. So, SSDs everywhere would be great, but most organizations don't have budgets for that. So really maximizing where you're putting the high performance pieces is very important to get not only the most out of your investment, but also not have to either waste money or miss out on an opportunity to increase your performance at not a lot of cost. Scalability considerations, those are really going away because CephFS matures as it's better supported. You heard that it can scale massively at this point. Now, the things you have to watch out for, obviously, is you've got a single point of well, it's not even a single point of failure because it does happen automatically in the back end, but you want to make sure that your architecture is set up so that your network environment, everything else around this is also scalable because, yeah, even if Ceph can fail over and handle everything automatically, if your WAN bandwidth isn't high enough for replication between sites or things like that, you still have to watch out for those issues. Same as you do with any other storage. This is nothing specific to Ceph. Access from the Docker hosts. Again, there's a lot of different ways Docker could access a Ceph system. I'm just going to be showing CephFS today, but depending on your applications, depending on the workloads, whether it's small file, large file, something in memory, something with very transactional, all those different types of issues are important to understand when you're architecting how you're going to be accessing this. For some workloads, Flocker might make the most sense. Others, you might want to go right through the RBD. CephFS is an easy one to demo, so I'm going to show that. So my demo today will feature none of these things. Because it was too painful to try and make work through the usual setup, it turns out Ceph deploy really is still just the best way to deploy and manage these things. So it's going to be a little bit easier. I've got on my laptop 3 different VMs. They are a combination OSDs and Mons for those in the Ceph world. I've also got one of them designated as a metadata server. And then I'm going to be using a SLE12 SP2 host for my Docker instance. And I will also be showing it for my laptop OS, which is OpenSUSE Leap, accessing the volume just to show that it really is fully clustered, everything's transparent. So while I'm jumping into the demo, any questions about any of that?
Yeah, one question at least. So I've been cool with CephFS, but with block devices, you need to install a little bit of software on the client to mount the block device. My question is for
what needs to be on the client?
What's the Ceph, software that you have to put in the Docker container to allow it to?
Sure, great question. So again, it's nothing in the Docker container itself. We're not touching the Docker container. The Docker host has to be able to access the CephFS volume, though. Now, in the case of SLES, it's just another kernel module. It's already built in and there and supported. I installed 0 software on the host that'll be accessing these CephFS volumes. Great question. Let me appease the demo gods. So again, I've got just a few different CES volumes here, nothing too exciting. So I'm going to disappear behind my laptop for a second. So what I've got here, just to show briefly, is Ceph1 is, I've got 3 Ceph nodes. Ceph1 happens to be the one I'm running as the metadata server, so it's kind of my most important one. Obviously, again, in production, you wouldn't want to have your OSD and your Mon and your metadata server all on the same thing, but this is a demo, and I only have a laptop, so we're going to go with that. If I take a look, you can see I've got 3 OSDs. Even in demos and things like that, I prefer to not run everything on one, but you certainly can. So I've got 3 OSDs, 3 Mons, 1 metadata server. If I look at my pools, can everyone see this okay? Excellent. So in my pools here, you can see I've got a few different spaces, but the important ones are I've got the CephFS data pool and the CephFS metadata pool. It's important to keep those separate for performance reasons, and the metadata is where you're going to want to put your SSDs, things like that, to get the most bang for your buck. Is that? I saw a flinch from Lars. Was that inactive?
No, you can have multiple data pools. That's a pretty unknown, not so well-known secret, but the rest is, yes, metadata. And obviously, this leads to Windows in the room. You want your metadata to be on NVMe, right?
Even better. Yes, yes.
The metadata is not usually large enough that the cache will make sense. You could create a separate pool that shares the OSD.
Perfect. That answer all the questions for now? Again, please keep this interactive. You have a great chance to win shot glasses. I say great because it's really 100%. At this point, you all can get shot glasses, so don't be afraid. So I've got this Docker host here. I was really lazy. I just built straight SLS12 SP2. I added the containers module. I've done almost nothing else to this. The one thing you will want to see oops. So I've got this mount point I've done here, and just to, I guess, make it more interesting, let's unmount the CephFS volume so you can see what that looks like when I do mount. So this is what the command looks like here. When I'm going to mount this on this host, just to go through that briefly. So this is a regular mount command. It just has a few more options than you're used to. So I'm telling it that the file system type is Ceph. I'm going to specify the three different OSDs I have that are part. Oh, sorry, the monitor nodes. See, I know I'd make a mistake sooner or later. So I've got the 3 different monitor nodes here. I'm just using the one pool for now, and then where I'm going to mount them to. And then the options I'm going to pass to it, I'm telling it I'm doing it as admin. I'm using my admin key. I've not set up CephFS authentication or anything else. It is not sophisticated. This is a very minimal demo. In a production environment, obviously, you would do things a little differently than this. But so there's no client installed on this Docker host. There's no Fuse modules. There's nothing I've had to do to my system to get it to work with this CephFS mount point. So just to reiterate that enough, I've not touched my Docker images. I've not touched my Docker host. None of it has anything special to work with CephFS.
Except SP2.
Yeah, yes. Sorry, good consideration, yes. Yeah, so I'll go ahead and mount that. Nothing too exciting. Look at my kernel messages. You can see there's libceph doing its thing, but nothing too exciting there. I can look and see that I've got these files. I've got an empty directory with MySQL. I've got a test file called test, and that'll become more relevant in just a minute. So the next thing I'm going to do is, I was too lazy to actually create my own Docker instance, because that's a lot of work. You have to create a Docker file with about 6 lines in it. And why do that if I can use someone else's? Which is what I did. I found someone else who had built a OpenSUSE-based MySQL Docker container and pillaged their work, because why not? That's what we do here. And so I'm going to run this command here. What that's going to do is tell it to run. I'm naming this MariaDB. And a lot of times with Docker instances, when they do maintain state, again, you want to pass configuration through the environment. So I'm telling it that when it's first creating this MySQL server, I'm going to use a really secure password. I'm going to use myself as the user. I'm telling it the database name to create is going to be SUSECON. Or no, that's another super secure password. This will be the database name. And then the important thing here is this little flag. So I'm telling it to map the volume. In this case, that's /mnt/CephFS_Docker/MySQL. That is what's on my CephFS volume. So I mounted that CephFS volume locally to this mount point. And then as far as this Docker instance is concerned, it's just going to think it's varlib MySQL. So I'm not changing the Docker container. This container is actually 2 years old. I'm using a really ancient Docker container just to show that it doesn't matter. There's nothing special with the Docker container. And this is the lovely person who created this. I have no idea who that is, but that's the image I'm using. So if the Docker gods are happy.
So that last argument is the Docker image you're going to.
Yes, the name of the image, that's correct. Yep, great question. So we'll spin that up. And again, when we looked before in that MySQL directory, it was empty. Oops. I'll check in my CephFS Docker. Lo and behold, you can see the MySQL data lives on the Docker host. It is not within the Docker container. But more importantly, if I go to, this is my local system now. Oops, I have to mount it first. Same mount command I'm running on my local OpenSUSE system. And if I take a look, I can see all the same data. So this is fully clusterized. You can access from all your different hosts at the same time. Obviously, if they're writing at the same data at the same time, you're going to have a problem, but that's the same with any clustered file system. So just to show, just to prove that it's writable by both sides, we'll make this new file called SUSECON, where before we had MySQL and test. Now we're going to add SUSECON to the mix. If we look from my host here, now there it is. So this is accessible by however many thousands, millions, whatever, however many Docker hosts I have. In this case, one. Not that exciting. But for however many hosts I have accessing this, they've all got access to the same data so that this Docker image can go to any host in the environment and everything will still run the same. Now, because this is also talking about Docker a little bit, and because I do still have a little bit of time, I'm going to go ahead. I'm going to shut down this Docker instance. So it's going to shut down, hopefully cleanly, the MariaDB instance. And then I'm going to blow it away completely, make sure it's gone. But I'm going to leave the data there, because one of the things we talked about is having the configuration all in state. So when I first ran this Docker image, I had to tell it the name of the database, the password, everything else I wanted it to use. But now that I've started it for the first time, I don't need that anymore. So let's go ahead and launch it. We're going to give it the same name. We're going to tell it where the volume lives with all that data, because again, we've got a lot of data already there to work with. We don't need it to initialize the database because we don't want to keep overwriting our data every time. That doesn't do us any good. Your application's not going to work very well if it's every time you run it, it has to start over from scratch. Some applications, yes, but most of them, no. So we'll go ahead and run this again. And if I check, I can see this instance is indeed running just fine. It did not need me to pass all the information across because it already had everything it needed. If I look at the log, see that it is, everything's running. Guess I didn't shut it down totally cleanly, but the end result is everything there just kind of worked. So the data stayed where I needed it to. The data lived in CephFS volume on my cluster. Everything is where it needs to be, and I could run that Docker image from anywhere else. So if I killed it there, if that host died, if whatever happened, I could have spun up that Docker image from anywhere in my network, attached to that CephFS volume, and everything would have been consistent and carried through.
Isn't there an argument to actually move that to the container? That responsibility for now to the file system, because otherwise you've got to have that now. You haven't got to then manage that. And you necessarily got to do that extra work on the underlying hosts.
You do have to manage it somewhere. So in this case, because it's an in-kernel driver, I don't want my Docker containers to be able to have all the capabilities and system capabilities to really tweak those things. It's kind of a security problem. There's something to be said of being able to pass a mount point as an environment variable and things like that. So I do see the benefit of that in this case, though, because I don't really want to have to manage my Docker instances. I want them just to be there. It's going to be easier for me to manage my Docker hosts. So that's where I could use SUSE Manager to make sure that mount point's the same and consistent. And again, these CephFS volumes are massively scalable. So while you can have multiple pools and multiple volumes, you can do it all with one, two. There's different ways you could do it. In my case, I created a folder called MySQL, and that was for this image. You could create whatever directory structure you want, do things that way. For performance reasons, sorry, Lars, I'm going to put you back on the spot here because you showed up. For performance reasons, though, it's a good question. Is it going to be more beneficial to have separate pools and volumes for different Docker containers, or is one flat pool going to offer the same character?
Yeah, I mean, if they so you would decide. Okay, so ultimately, that's a good point. You don't want to manually be managing those mount points. Ultimately, the container orchestration infrastructure, let's for purely hypothetical reasons call it Kubernetes, would obviously take care that the host is capable of satisfying the requirements of the container. Like network setup would be another thing, right? Registering with a local. So those are all the environmental things, like including providing the file system mount so that you can actually start the container. Normally you would share one file system maybe per tenant, but it could be on the same pool if you have the same performance requirements. Otherwise you would have different pools, but what you actually do is you would slice different directory trees out to your various Docker containers, right? So and there is a Docker driver that handles mounting the file space as needed. You know, so that certainly that can be optimized. But the base, the end result will look inside the container. So inside the container, you will never know, right? Inside the container, you have this magic space where files appear, just like with OpenStack Vanilla. In the VM, you don't know where that is coming from. It's all automatically configured for you as long as the driver is there.
Yeah, and another good reason to do it this way too, independent of the container, is if my developers want to work on an instance and they're in an airplane or something like that, they're not going to have the network set up or anything else to reach your Ceph cluster. So I don't have to actually map this volume. I could put it to a local directory on my system, and the application is going to work exactly the same, regardless of whether it's a Ceph backend or anything else. So the less you can have in the container image itself, the better, because you're taking all those pieces out.
Yeah, and just abstractly to add to that, the idea of the container is that, like you said, it's as thin as possible, and you're really focused on the app. You know, if you do have, let's say you had 2 separate locations, and each one of those locations gets to your data center a different way. Now you suddenly need to manage 2 sets of Docker containers that have, you have one image for one data center, one image for another data center. You know, if that was the case, we wouldn't have been able to use this third-party generic container that someone developed 2 years ago.
Yes, I mean, expanding on that point even farther is Crispin Cohen was one of the lead developers for AppArmor. I don't know if he came up with this quote, but he told me, you know, it makes perfect sense. A good application does what it's supposed to do. A secure application does what it's supposed to and nothing else. And it's the nothing else that we're really focused on with containers, because you're wrapping them in this tight little box. This is all they can do. It's all they need to do. They don't need to worry about the rest. So the less intelligence we put in that container, we want to strip that down to just the bare minimum. Nothing else should go in there, because everything else you add expands that security footprint. Everything else gets messy. So yeah, we try and keep that as tight as possible. And if you did have something hypothetical like Kubernetes managing those Docker hosts, you know, even better, because you're abstracting those layers away. But yeah, then you get that consistency between all your different environments.
So container question, I realize you're doing CephFS. If I wanted to do RBD or S3 in the container, same. I mean, I don't need any, do I not need any software just like I don't need any? So on the Docker host, you would be doing things differently. So I showed CephFS because it's the most transparent and it's the easiest to you know, it's, they're not native files. No, they're not POSIX file systems. They're nothing like that. It's a whole different model.
There is a Docker driver that will essentially map an RBD device, you know, and mount it as a file system, and then obviously that's exclusive access, right? But there's a Docker driver that does that. If you're doing S3 is a pretty high-level protocol. So if you want your application to speak S3, right, you would not, then your application would be using the whatever Python, Java, C++ library to speak that protocol with a persistent store, and that's something that would not be handled on the host, because that, you know, it's a different level of interfacing.
Yeah, there's you know, obviously there's layers you could do it within your container with something like S3. There's different ways you could do it with the Docker host, with RBD. So there's different ways you can do it, but you know, it's just going to depend on the application logic and where it makes the most sense, as well as performance and other considerations. But again, there's my plug for NovaCoast. We'd love to help you.
Container question. One last question then. The Docker drivers that Lars talked about?
Yes.
Are those things that when you set up your Docker, you know, config file or whatever, those things you have to put in there, or depends? Or you just get there?
It depends. They're all different. There's probably a dozen different ways I've seen of doing Ceph with drivers in varying states of development. So because that's a little more outside the box, I went with the easy thing. But yeah, there's a lot of different options out there.
Thanks.
Sure. But that's really all the things I had. It's free question time, free shot glass time. Anything else, people?
Who didn't get a shot glass?
He gets 2. Excellent. Oh, he's got 2 hands. The math works out. This is perfect. Any other questions, concerns? Anyone excited to go out and use Docker with Ceph? Yeah, there we go. See? This is cool stuff. Yeah, and
What do you put into our shot
Come by our booth and I'll show you. Yeah, you have to come by on vendor night. That's the secret. Come by the Nova Coast booth at vendor night and you'll be rewarded. Oh, well, the booth is closed. I'm sorry. So at this point, you just get an empty shot glass. Next year at SUSECON, come by the booth.
Did you re-engineer? Did you rewrite from scratch, or have you got stuff that doesn't really need to Docker?
Everything.
You can do anything you want.
You can do anything you want. Yeah. So for what I showed, everything was very vanilla. I followed the SUSE docs exactly to set up CephFS. I used someone else's Docker image. I didn't do anything special at all. You can get as custom as you want and do things however you want.
No, this is more about my teachers. I'm asking about, I guess, when you're working with clients and how you've done it.
Oh, sure.
You got into the whole CI thing and doing it properly. We've had some small internal applications, but we've got web apps which I think would work well with they are.
Web apps are great.
If they're not, they're still probably for
Yeah, so a lot of the work in the Docker world is getting those application workloads ready for Docker. So there's oftentimes hard-coded configuration, things like that. You've really got to clean up and abstract away in some of that piece. But yeah, web apps are ones that are very popular for Docker because they are generally stateless. There's not a lot of interdependencies. It's a good one. But yeah, those are good ones to start with. But yeah, that's something we do a lot with customers is help them figure out how to get that workload Dockerized. Or sometimes it doesn't make sense. Maybe we just have to get them to the microservice model first. But yeah, figuring out what to Dockerize and where and how to do it, that's a big challenge for a lot of shops. And it's a totally different paradigm shift, too, to managing it because you have to understand. Yeah. So if understanding that, wait, I don't patch, I rebuild, I redeploy, it's a very different model. And there's a lot of tools you need around it to make that successful. You can't just decide, oh, I'm going to Dockerize everything tomorrow. You've got to have the whole CI build system around it and all the other tools, and everything really changes. So it's not something that happens overnight, but
Can you name few applications which you would Dockerize in that environment?
Sure, so web applications, again, are a big one. Our entire environment is mostly web applications. We've got database servers, we've got directory servers. For a lot of my customers, I've done security services, so OSSec, things like that, lots of different utilities. Elasticsearch is one, the whole Elk stack. It's a lot of open source products. They've already got Docker containers out there. You can just tweak them a little bit to fit what you need. But yeah, I mean, you go on GitHub or you look up the Docker files for all the things in Docker IO, and there's a million applications already out there done that way. Usually you can kind of start with one of those as a base and tweak the Docker files and other things and get your application running. But yeah, the simpler services and the fewer dependencies it has on other services, the easier it's going to be to get up and running.
So if you work with any traditional databases like Oracle or DB2 or something, can you Dockerize them?
You can. I've not seen anyone do Oracle, but again, it gets into the size of those application dependencies. So Oracle's not the easy. So the other piece is when these Docker files themselves, they're basically, if you can script out an installation, you can put it in a Docker file. Some of these applications, they've got GUI installers or things like that. That's going to be really hard to Dockerize because now you're basically rewriting the installer to fit into a shell script, basically. If you've seen a Docker file, it's almost entirely a shell script. You're putting in some specific language around what base OS you want to start with and all the different layers and things like that. But largely the application installation is just whatever you can script. So if you can put it in a shell script, if it's something that breaks down to that level, you can Dockerize it. Oracle and some of those are kind of tricky. Sure. All right, well, I hope you enjoy the rest of the show. Appreciate your time.